Hey friends, we're going to backtrack on our notes a little bit and go back to page 6 and talk about solving quadratics in the context of free fall motion again. Hopefully, if you've been paying attention and working super hard, this formula looks familiar from earlier in the year where we're going to be giving you guys information. There's one, two, three, four different unknowns in this equation, and we'll always give you at least three of them. You just have to understand which each one represents. So a quick refresher, h of t means the height at any given time t. So the idea of an equation is it allows us to predict things, right? So if you tell me a specific time, I can plug that time into my equation and I can tell you a specific height. That's what h of t is. H of t is like the height at whatever time we plug in. So if I want to know the height at 3 seconds, I would find h of 3, meaning I'd plug 3 into my h equation, and whatever answer comes out, that's the height at 3 seconds. When we're talking about it in general, we just say h of t, and that means look, you tell me the time, I'll tell you the height. That's what h of t is. H sub 0 is the starting height. So all problems begin when you have stuff flying in the air. There's always a moment where they get put into the air and they have an initial starting height. That's what this h sub 0 over here represents. T is the time in seconds, and then v sub 0 is at starting velocity. The starting upward or vertical velocity is what v sub 0 is. So hopefully you remember that stuff. We're going to go ahead and complete some of these examples on page 6. Some of them we're not going to worry about right now, but I'm about to... the important thing actually before I even pause the screen, I want to let you guys know is one quick thing. So in a lot of our problems that we're going to give you guys, we're going to say something like, this fishbowl was dropped, or this Jolly Rancher was dropped, or this book was dropped. If you're dropping something, if I take a pen, for example, and I decide to drop it, the initial starting velocity is 0. I'm not chucking it on the ground. I'm not throwing it up in the air. I'm simply holding it, and then I release it. Starting velocity is 0. So you guys want to be on the lookout for this word dropped. And when the word dropped is in your problem, this part of the equation goes away because v sub 0, the initial velocity will be 0. 0 times anything is 0. So it gets, it just disappears. We're not going to worry about it. There's another thing I want you to worry about. I'm going to pause the screen and write it out first. The other thing to be on the lookout for are the questions, how long is this object in the air? Or when does this object hit the ground? First of all, I hope you can recognize with a little bit of thinking that these are two ways of asking the same question. If I ask you how long something's in the air, that's the same thing as figuring out when it hits the ground. And when that happens, if that's the question you're asked to figure out, we're trying to figure out, we're going to replace h of t with 0. If h of t is supposed to tell me how far something is from the ground at any given moment in time, when something hits the ground, its height from the ground at that moment is 0, and this represents that height at any specific time. We want this to be replaced with a 0, like the whole thing. I'm not saying plug 0 in. I'm saying replace h of t with 0, and we're going to see that in the example that I'm just about to do right now. So right now, I'm going to pause the video and clear the screen. So if there's any information on here that you find useful, that you haven't put in your note packet yet, you might want to do that right now. Because I'm going to clear the screen right after I finish this quick pause. Pausing the video right now. Now, for today's lesson, I do want to keep things as simple as I can. So what we're going to do is imagine a scenario where we're dropping an Algebra 2 book off a 200-foot cliff. Hilarious, right? So we're going to take this book, drop it off the cliff. We're going to skip part A for right now. We might come back to it, we might not, I'm not really sure. But I want to look at this portion of the question where we're saying how long will it take for the book to hit the ground. So we do definitely want to bust out this equation, this generic equation, negative 16 t squared plus the initial velocity times t plus the initial height. And we're going to take this question and get an equation we can actually work with. And I'm noticing, of course, a few key things. Key thing number one that I notice, we are simply dropping that book. We are holding it and letting it go. That means that the v sub 0 portion is going to be 0. It's just going to go away. So that's great. If you hear screaming boys, it's my son and his friends playing outside. I do apologize. The textbook is 200 feet off a cliff. So that's the starting height. So we'll have a negative 16 t squared. We know the starting height is 200. And the question is, how long will it take for this book to hit the ground? So we're basically asking, when is the height from the ground 0? You know, right now, the height at the start of the problem, the height is 200 feet. It starts to fall. I want to know when the height is 0. And my hope is that this looks like a very straightforward problem that we've been working on and solving. We're going to solve this for t by doing the following things. Well, I'm going to do PEMDAS in reverse is what I'm going to do, right? So if you're unclear at all, if you're ever doing algebra and you're a little bit unclear and there's just one kind of unknown in the problem, draw yourself a little PEMDAS tower. We're going to start our way at the bottom, work our way up. We're going to imagine a big line right down the middle. I'm going to look at this t squared. That's what I want to isolate. So I'm looking at this side of the equation, and I'm saying, is there anything to add or subtract? And I can see that I can subtract the 200 from both sides, giving me negative 200 equals negative 16t squared. Move up the ladder and ask myself, okay, we're still looking at this side. T is still not by itself. They multiplied by negative 16. I'll divide by negative 16. And I'm going to need to use a calculator for this one because this is supposed to be like a real world problem. So I want to give like real world type answers. So we're going to be working with decimals anytime it's a real world application type problem. So let me pause and get my calculator out. And I can see that it's going to be 12.5. That's what t squared is going to equal. I'm still focusing on PEMDAS over here. I'm going to go up the ladder. I can see it's t squared. So there's an exponent to get rid of. I'll square root both sides. And because it's a real world problem, I'm not going to bother with that plus or minus business. I'm just going to square root 12.5. And I'm just going to put that in the calculator, and whatever decimal I get, that's the decimal that I'm going to use. So after doing that quick calculation on my calculator, I got, I think 3.54 is my final answer. And so how long does it take the book to hit the ground? 3.54 seconds. I hope what you guys can see is it's a very straightforward application of stuff we've been practicing. We're going to be on the lookout for the phrase dropped. And when we see the phrase dropped, we know that the v sub 0 portion of the equation is going to go away. We're going to look for a starting height and put that in for the h sub 0. And when we're trying to figure out how long it takes them to hit the ground, we're taking whatever expression we have, we're setting it equal to 0, and we're using all those skills to solve it. Good luck with this today. There's an assignment. It's in Classroom. Give it a try. It's pretty short, so it shouldn't take you too much time. And I will see you guys on Thursday. If you haven't done your 1.3 assessment yet, please do it. Some of you, just do it. Thank you. Have a good day.